This is another of my Arduino-based projects to improve the action of vintage American Flyer accessories. In this case, it's the 769 rotating aircraft beacon. I had several junk box beacons in various stages of disrepair, so I thought I'd try to make one or two good ones from the collection of pieces. This one is more of a mechanical challenge than an electronic challenge. Originally, these used a 461 dimple bulb to heat the air and cause the beacon to turn. The problem is the dimple bulb is a 14-volt bulb and they run it at 16 volts to generate enough heat to cause the beacon to rotate. This results in short bulb life, and if the beacon falls off and you don't catch it in time, the plastic lenses can melt. So I used an Arduino microprocessor, again, another little board that I made. Arduino microprocessor, power supply, bridge rectifier, and so forth. And that drives a stepper motor to rotate the beacon. Now these stepper motors are available on eBay and Amazon for about $3, including the driver board. And I ended up using some of the parts off the driver board on my final board. Okay, the biggest problem with this thing was making up a ring of 20 high brightness LEDs to light the beacon. That was probably the biggest challenge, as I made two brass rings by wrapping some thick brass sheet around the top of the beacon and then tacking them together with solder. Then I soldered on 20 surface mount LEDs, making sure the polarity was all the same. Once this was done, the cylinder of LEDs just slips over the top of the beacon bulb holder. I removed the bulb socket and I used a 12mm outside diameter ball bearing in the socket. There's a spacer screwed to a piece of 1/8" brass rod which connects to a coupling, a little coupling here on the stepper motor. And the ladder is one side of the light circuit and the tower is the other side. The brass rod that you might be able to see here in the center is actually 1/8" brass rod that I got at my hardware store. It's approximately 3mm, so I got a shaft coupling since these things are metric, and it's 5mm on the motor side and 3 on the brass rod side. And I used that to couple the, might be able to see it here, to couple the motor to the brass rod, which then turns the shaft coupling on the top that the beacon is screwed to. So I used the lenses from a damaged beacon to make a new one out of thin-walled 1-inch plastic pipe. I just drilled some holes in it and glued the lenses to it, and it's attached to that spacer on the top of the screw. Since I don't need the vanes anymore, I think it adds a little bit of realism to it. Okay, the stepper motor is commercially made by the hundreds of thousands, and what it's used for is it's used to wave air conditioning louvers up and down. So you can find these things on eBay and Amazon and so forth for like $3 for a stepper motor and the little board to drive it. So again, I used a bridge rectifier and a buck converter to power the Arduino and the LEDs. They're very cheap on eBay. And again, this allows me to use the standard 16 volts AC from the American Flyer transformer, just as the original accessory used. I'll stop it here now for a minute and see if I can take the beacon off and show you the ring of LEDs and how I mounted the motor. So let me just unscrew this here and lift it off. And don't know if you can see this, but there's the ring that's got the 20 LEDs on it. You can see that one wire connects to the ladder, the other wire connects to the tower to bring the voltage up for the LEDs. And then on the bottom, here's the motor just screwed into the base of the accessory. So let me try to put this back together again. Difficult to get it on here. And turn it until it starts spinning in again. And once it's screwed in, I can turn it back on and it'll start turning immediately, which is much better than the original. So it's fun to imagine how these accessories could have been made had modern technology existed at the time. Again, my next project is an Arduino-based board to emulate the talking stations with an MP3 recording of one of the records and also control the stopping and starting of the train. So stay tuned for that project, and again, thanks for watching, and please subscribe for future updates. Thank you.